Welcome to EDU World Space.
Hi everyone, here it is given. A rocket is fired at angle from the top of the tower of height 50 meters as shown in the figure. Because of the design, the engine, its position coordinates are changing with time according to the relation. X coordinate is changing with time according to the equation a plus vt square, and y coordinate is changing with time according to c plus dt cube. Here A, B, C, D are constants. It is given that at t is equal to 1 second, acceleration of the rocket is 4 I cap plus 3 J cap meter per second square. Take the origin base of the tower. So this is the origin 0, 0. First part, we have to find the coordinates. We have to find the value of A, V, C and D. B part is given. We have to find velocity vector and acceleration vector at t is equal to 0. C part, we have to find x and y component of velocity vx and vy at t is equal to 10 seconds, and we have to find the position vector r at t is equal to 10 seconds after firing. So here we write at t is equal to 0, x is 0, y is 50 meters. At t is equal to 1, acceleration is along x direction is 4 meter per second square, and along y direction it is 3 meter per second square. Now we will evaluate the constant A, B, C, D. Part A. So velocity along x-axis you may find dx upon dt. X is given A plus vt square. So you will get twice of vt, and acceleration along axis is dvx upon dt, that is d upon dt of 2 vt. So it is twice of the. At since ax is independent of time and ax is given 4 meter per second square, ax we have measured twice of the. Ax is 4 meter per second square, so value of v will be 2 meter per second square. So one answer we have obtained. Now vy is equal to dy upon dt, and value of y is given c plus dt cube. So you will get 3 times of dt square. And acceleration along y-axis dv by upon dt. So it will be d upon dt of 3 dt square, that is 6 dt. So acceleration along y-axis is given 3 meter per second square at t is equal to 1. So you will get value of t. Your d you may calculate. Ay is 6 dt. Here ay is 3. Time is 1 second. So value of d will be 0.05, sorry, 0.5 meter per second square. I am underlining it in the box. Hence, at t is equal to 0, x is 0. So a will be also 0. At t is equal to 0, y having 50 meter. So v is equal to, sorry, c is equal to 50 meter. So these are the, I am compiling the values here. For answer A, value of A is 0, value of V is 2 meter per second square, value of C is 50 meter, and value of D is 0.5 meter per second square. Now B option, part B, sorry, at t is equal to 0, Vx is 0, Vy is 0. So velocity will be also 0. At t is equal to 0, Ax is 4.0 meter per second square, and Ay is 0. So net acceleration at t is equal to 0 will be 4 I cap 0 j cap meter per second square. C part. At t is equal to 10 second, Vx you can find 2 into 2 into 10. So it will be 40 meter per second. Vy you will get 3 into dt square. So d is 0.5 10 ka square. So you will get 150 meter per second. So velocity after 10 seconds you may write 40 I cap plus 150 j cap meter per second, and its magnitude would be root of 40 ka square plus 150 ka square. So this value would be 155 meter per second. D. Position of rocket after 10 seconds of firing. So first we will find position along x-axis. So in the equation of x we have to substitute the value of x. You will get 2, that is 200 meters by 50. C is 50. D is 0.5 into t cube, 10 ka cube. So on solving it, you will get 550 meters. So radius position vector will be xi cap plus yj cap. So you may write position vector of the rocket to be 200 I cap plus 550 j cap meter. That's all for this problem. Thanks for watching it.